Hello guys, welcome back. In this video, let us observe and analyze MLM, that is nothing but mask language model. Or you can say, if I given a sentence to my model, then my model need to predict the word. So what is masked? Or you can say, our model need to predict what is the word that is not given inside the sentence. This MLM, or you can say masked language modeling, is also used as a technique in order to pre-train ML models, NLP models, or some transformer models as well. Now let's see hands-on how to do this. That is a mask language modeling or predicting the word inside a sentence. So what is my task? MLM. Nothing but that is nothing but predicting a word inside a sentence. In short, we call it as MLM, mask, masked language model. So this is what we're gonna do right now. Now for this, so in order to predict a word inside a sentence, I have two tasks. One is create a sentence, or you can say I want to first create a sentence, create a masked sentence. This is the first task I want to do. Second task is I want to predict the masked data, or you can say masked word. Now let's see how to create a masked sentence. So let's take a sentence that is I want to eat an apple every day in the morning. So like this, I want to take a sentence, sample sentence. Now I want to predict this word, and here I want to provide some mask. I want to provide some mask here. Now I want to create this mask. That is, I want to define this mask. So at first, I want to define this mask. To tell my model this is a mask, so you need to predict that word present at that mask place. For this example, let's say I want to take a model that is a BERT-based case model. So let's write that as well. The model that I want to use, that name I'm taking, BERT-based case model that I want to take. Now, for this model, how it can able to predict here this is a mask. So in order to tell my model this is a mask, in tokenizer I have a token to say that a particular word is a mask. So in order to say a particular word is a mask, let's import the tokenizer. So where my tokenizer is there, from transformers module I have my tokenizer. So that's why I'm importing that auto tokenizer from my transformers model, and I'm creating that tokenizer by using this auto tokenizer dot from already pre-trained models. That is my model name that I've already stored in this model name variable. So now my tokenizer I've created. In order to create this mask, I want to use this tokenizer, and inside this tokenizer you can say I have mask. So what is that? Mask token is there. Mask underscore token option is there. By using that, I can able to define my mask. Now you can see I have defined my mask by using a tokenizer's data. Now, if I pass the sentence to my model, then it can assume that this is a mask. You can even print this sentence to see. No, it's a MLM, right? Yeah. So let's stop it. Space MLM dot py. It will just print this sentence, and here in this place it will assume the mask. which I was created from the model related tokenizer. You can see the output to check how we are getting. Now you can see, so a mask token was created here. Now, so we created a sentence with a mask. Okay, now my sentence is ready. That is this. So I just print it. Then I want to predict the mask data. So in order to predict the mask data, first I want to pass this data to my model, right? Yes. So I want my model. So how can I able to get my model? That also present in my transformer. So that's why I'm defining here. What is the model name? My model name is nothing but it's a auto model for masked LM. So let's import it separately so that you can able to understand. It also present in a transformers. I'm importing it. Auto model. Auto model for, you can see multiple options are visible here. So among them, what I need for which case I want masked. So you can see masked LM, masked language model. So that I want. You can see I've imported that. So by using that, let's create a masked language model for this model name. So auto model for masked language model dot from pre-trained model, that is nothing but what is the model name that I'm providing, that I have stored in this model name variable. So that's I'm providing. Okay, now we defined our model. Then after I want to use this model. I want to use this model in order to predict the masked word. So how can I able to use this model? I want to pass this sentence to my model to predict the output, to predict the masked word. So in order to pass this sentence to my model, first I want to create an encoded sentence, right? Yes. So I have just a normal sentence, that is a word type sentence. I want to create an encoded sentence. So that's why I'm using this tokenizer. So whatever the tokenizer that I have previously created, that tokenizer I'm using and passing what are the sentences that I have. And so what is the return type I'm expecting? The return tensors I'm expecting is PyTorch. PyTorch type tensors I'm expecting as a return value from this encoded sentence. Then whatever the encoded sentence I have, this we can able to directly pass to our model. To predict the output, I want to pass this encoded sentence to my model. So double star encoded sentence. Now I get the output. I get the output. So this output actually contain the predictions of which word has most probability to came here in this mask place. So let's print the output to analyze what do I get. So then after we'll make it arrange to get the exact predictions, like so it will predict you the embeddings. You can see first the sentence got printed, then after you can see multiple embeddings got printed. So I'll tell you what are these. You can see this is a sentence that got printed. Yeah, these are general warnings. Please ignore them. Then you can see this logis. This logis. So what is this logis, sir? This logis actually contain the predictions and the probability scope of which word may come in this masked place. So let's see the top five. Let's see the top five words which may come at this masked place with their probabilities as well. Now I want to see the logis. So you can see I want to get the you can see where my data, or you can say where my predictions are available inside this logis, right? Yes. So let's pick the logis out of this output. Logics. So how can I able to get this? Output dot. So where it was logits, right? Yeah. Logits. Now I'll get the logits. Let's detach it. And so let's use a numpy of 0 to get the logits. That is nothing but this logits I'm getting. Now let's print these logits, whatever we got. And I think here there will be mistake, that is a dot is missing. Yeah, let's run this. Yeah, there is no errors are visible right now. Okay, let's see the output to see the logits from the output data. Then what we want, we want only this data, right? We want only this mask data, and I don't want all other things. So what is the position? What is the position of this mask? So in order to identify the position, we need to convert this sentence into tokens so that we can able to identify the positions. So let's create the tokens by using a tokenizer with tokenization tokenize tokenize of this sentence. Then we can able to get the tokens. So let's print the tokens at last so that we can able to identify, or yeah, let's print the tokens so that we can able to identify it. And I'm running it to see the tokens, and exactly I want to identify this position to print only that particular position related logits to identify the predicted words at this position. You can observe 0, 1, 2, 3. Nothing but yeah, you can assume it like a length of, or you can say index of this sentence, index of this mask. How can I able to get that masked tokens, or you can say logits from all logits? So just pick that position tokens in the logits. I want to pick only this mask position related logits. So in order to pick that, I'm just using the tokens dot index to find the index of my mask. In this mask variable, I defined the mask. You can see this is the mask. Plus 1 will provide me the exact position of this mask. So these are the actual mask logits. Mask related logits now we'll get. Now we'll get the mask related logits. From the data, we can able to identify the predicted scores as well. So based on the predicted scores, we can able to predict a particular. You can see these are the logits related to this position mask. Related to this position, these are the logits. Now what I want, I want to see only two things. What I'm expecting is I want to see two things. The first one is the scope, or you can say the score or probability. The probability I want to see, as well as what is the item or what is the word and their probability, word and their word probability I want to see. That's it. What is the word that may came at that position, and that word related probability I want to see. So in order to find that, we need to import one more function, that is from scipy. From scipy dot special, I'm importing this soft max. I'm importing the soft max from scipy dot special, and now I want to use that to find the probabilities. I'm copying this. Yeah. Or you can say confidential scores or probabilities. Confidence scores. I want to get it from this by using this soft max. Now I'm providing my log, or you can say mask logits. So whatever I find right now, that I'm passing to get this confidence scores. Now let's print it to see the confidence scores. Yeah, you can see these are exponential terms, right? Yes. And you can also observe so on. That means multiple values are there and they are not in any sorted order. What I want, I actually want top, or you can say highest probability or confidence score words. Let's say I want a top 5 values only. So in order to first sort them and get only top 5, so in order to sort them, we can use a NumPy so that it will be faster. So I'm using NumPy, and by using that NumPy, I'm using this arg sort. By using this arguments sort, I'm providing here what are the confidence scores that I got. And in this, what I want, I just want the largest one, right? So that I'm picking like this. That is, this arguments will sort from smaller to larger. This this syntax will get me the reverse order. That means the largest value to smallest value. And what I want only top 5. So that's why I'm writing it this. This will pick only me the top 5 values, and you can just get them by using for loop. So for each value in this, for each value in this, what I'm getting, I want the word from those values. So how to get the word? By using the tokenizer, you can able to decode the value to get the word. And how do I get the score? Or you can say, how do I get the probability of that word to be the result? So to get the probability confidential score, you can able to use confidential scores of this is nothing but the previous scores that you created of that particular value that you need to provide, and just print the word and the probability so that you can able to identify which word may come next. So the word as well as the word probability we are printing right now. Let's see what do we get. Which word maybe probably came here. Let's see. Yeah, these are the small warnings. Just ignore them. We need to get a word as well as that word probability. That probability defines me. So here in this marketplace, that word may come. So what is the probability of that word may come? You can say I want to eat an apple every day in the morning. So for eat, this is the probability. Since this is the highest probability, maximum this will be the answer. You can say this as the score as well. And these are the top five values or top 5 words may come in this masked place. You can say, I want to get an apple. Yeah, seems to be correct. I want to get an apple every day in the morning. Yeah, that also seems to be good. I want to pick an apple every day in the morning. Yeah, I want to have an apple. Yeah, that's also good. Let's take it. I want to take an apple. Yeah. So each and every word is making a lot of sense, right? Yes. In this way, actually, our model will predict. So let's print a sentence as well directly. So in place of mask, I want to print this. So in sentence, I want to replace. So for strings, you have a replace function is there that can replace at this position, whatever the value that you provide. So at this position, what I want to put, I want to put the word. So what are the word that is predicted that I want to put here? This is the word that I've predicted that I want to put here. So that's why I provided. And these are the scores. So let's rerun it so that you can able to get the whole sentence as well as the probability of that word, or you can say that sentence is correct based on the mask. Actually, in this way, you can able to do MLM, that is nothing but masked language modeling, or you can say you can able to predict a word inside a sentence. We just taken, so let's recap it as well so that it will be very easy to us. In order to predict a word in a sentence, first task is we need to create a masked sentence, and second task is we need to predict that masked word. So how we created the masked sentence? We just imported the tokenizer from transformers, and we stored the model in a variable, and we loaded the tokenizer for that model. And by using that tokenizer, we initialized a mask, and I initialized that mask inside our sentence in order to predict the word which may comes at that position. And then at last you can see this how we created the masked sentence. Then we need to predict the word in that masked sentence. In order to predict what I want, I need to generate embeddings, right? Yes. So how do we generate the embeddings? By using the tokenizer, we need to generate the embeddings. So you can see we generated the encoded sentence by using the tokenizer and passing the sentence, and we are returning the PyTorch as tensors. Then you can see we initialized a model by using this auto model from masked language model. We imported this from transformers for our model. And whatever the encoded sentence I have passed to our model to get the predicted outputs. In that predicted outputs, I just want logits. So we're getting only that logits. And after getting that logits, so what do? We just identified our mask position based on that tokens. We just take our sentence and we created the tokens in order to identify the position of our mask. So by using the tokens, we identify the index, or you can say position of the mask. And so based on that, we picked only the logits related to our mask. And by using this SciPy special, we imported this softmax. By using the softmax, we can able to identify this confidence score. And based on this confidence score, we picked only the top 5. That means whatever the scores which are high, top 5 probabilities of a word that need to come at that masked position. Those top 5 words we picked, and you can see by using the tokenizer, we decoded the value of our confidence score. Then by using the value, we even predicted the probability of it, and then we just printed the sentence which may come at that position with their probability. You can see, so this is the most highest probability, that is a 0.6, or you can say this is the highest score, that the word may be this, nothing but the masked word may be this, that is this: I want to eat an apple every day in the morning. Yeah, this is what I thought while writing the sentence, or you can say while providing the mask. So this model is able to predicting this very efficiently. In this way, you can able to implement this MLM masked label modeling, or you can able to predict the word inside a sentence by using any one of the model. I hope this video is useful. If you like this video, then please like so that I can able to make such more videos. Please provide your opinion on comment section, and do subscribe to watch much more useful and knowledgeable videos from this channel. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye guys.